Okay, good morning, guys. It is Monday. It is October 26th, 10/26. The end of the quarter's here, so if you need to get anything done, retakes, homework in, you got to get it done this week because we're going to have the end of the quarter, and that's that. Okay, so today what we're talking about is simplifying square roots. Okay. Now, there are things called irrational numbers, okay? Irrational numbers. Okay, and those are numbers that never end, never repeat, they just go on forever. So an irrational number is a number that can't be a fraction. So an example, let me just show you an example. An example is the square root of 2. So the square root of 2 is an irrational number. It's really an ugly number. Like, check it out. Square root of 2. So 1.4121, blah, 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 blah. And then it never ends. This decimal keeps going on forever, never, never. Square root of 3 is an irrational number. Square root of 4. Oh, that is a nice number. What else is another nice number? Well, how about the square root of 9, right? Right? That's a nice number. But not the square root of 8. That's a bad number. That's an irrational number. So what we want to do is take a look at what we call our first perfect squares. So a perfect square is a number that has a square root, like 4. Well, obviously 1. Well, you can say 0 also. But let's start with, we know that 0, 1. But then we also have 4, because we know the square root of 4 is 2. 9 is a perfect square because the square root of 9 is 3. 16, 25, 36, 49. Let's catch up. 64, 81, 100. 121, because the square root of that is 11. And then 144, and it keeps going, 169, and so on. These are perfect squares because they all have square roots. Because square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, square root of 100 is 10, square root of 121 is 11, square root of 144, and all the rest of the numbers is 12, and all the rest of the numbers are just bad numbers. So sometimes, though, and this is our lesson today, sometimes we get irrational numbers, square root of 20, that might have a perfect square in it. So square root of 20 is an irrational number, but it has a perfect square in it. So what we're going to do is we need to find multiples. Multiples. Something times something. Multiples, 2 numbers. Well, I want multiples that has a perfect square. I want one of these numbers in my multiple. So 2 and 10, no. But I'm going to rewrite the square root of 20. I'm going to rewrite it as its multiples, as the square root of 4 times the square root of 5. I specifically want 4. I want the 4 because there is a square root of 4. Any other combination with 20 does not give me a perfect square. So I'm looking for one of these numbers. And the square root of 4, we know that. The square root of 4 is 2. It's a whole number, 2. And then the square root of 5. Now the square root of 5 we're stuck with. Because the square root of 5, whoops, hold on. Because the square root of 5 is an irrational number, ugly number. So we're going to leave it as square root of 5. But this is much more simplified. It's basically been reduced from square root of 20 to 2 square root of 5. We got one of its roots out. Okay, example 2 is the same thing. The 3 is already there. It's a whole number. So leave the 3 alone. The 3 is already, this 3 is already a whole number. But 18 can be broken down. I am not going to use 3 and 6. I am not, what times what makes 18? I'm not going to use 3 and 6 because what I really want is 9 times 2. Because the square root of 9 is 3, so I have a perfect square. So to continue simplifying this, I write down the 3. The square root of 9 is a 3, so I'm going to have another 3 times 3. And then the square root of 2, we're going to leave as square root of 2 because you cannot reduce it. It is an irrational number. Okay, now from here, 3 times 3 is 9. times, because 3 times 3 is 9, times the square root of 2. And we're going to leave it like that because the square root of 2 is an irrational number. I don't want an ugly decimal. I want a square root of 2. Okay, example 3. Example 3 is not that hard, but one of the things we see in example 3 is that you can break them up into 2 different square roots. You can rewrite it as the square root of 9 over the square root of 16. And if you break it up into 2 different square roots, then you can see right off the bat that if we have the square root of 9, we can rewrite that as plain old 3, because square root of 9 is 3. And the square root of 16 becomes a 4. So it becomes a rational number. Not irrational, but it becomes a rational number. Okay. Example 4, we can do the same thing. We can rewrite as 2 different square roots. Rewrite as the square root of 32 over the square root of 25. Okay. Now, I'm going to shoot this down over here so I have more room to work. But I know at least the square root of 25, the bottom, the square root of 25 is a perfect square. It's one of these, right? There it is. So I take the square root of 25, and I'm going to get 5. But now 32 is not. It's not. So what I'm looking for is 2 numbers that make 32. And I want one of these numbers here, okay? Now 4 will work, but 16 is better. It's like reducing. Pick the biggest one. So I'm going to rewrite 32, square root of 32 as the square root of 16 times the square root of 2. Because I can take the square root of 16. So I found 2 multiples, one of which was a perfect square. Square root of 16 is a 4. So I'm going to take the square root of 16 and have a 4. Bring this over here. Square root of 16 is a 4. Square root of 2 is just an irrational number. So I leave it the way it is. Square root of 2, we leave it as we do not want the ugly decimal. Okay? All right, now, number 6. Before we start 6, we have to go back and do a little bit of algebra. I know that x to the 4th times x to the 4th equals x to the 8th because you add exponents. Okay? So when you take the square root of something, there's an invisible 2 here. There really is. You're going to take half the exponent. Because the square root of 8 is 4. Because x to the 4th is x to the 8th. So same thing. We know the square root of x to the 8th is x to the 4th. Well, before I do that though, the square root of 81, the square root of 81 is going to be a 9, right? And then I'm going to take half my exponent, x to the 4th. There it is. It's completely reduced. Okay, example 7. In example 7, let's do this one. So the 3 is just a plain old 3. We're going to leave it there. And the square root of 27, let's see, we're going to break that down into, I need one of these numbers, probably 9, right? 27 is 9 times 3, square root of 9, square root of 3. But I cannot take half of the 7. I don't want a 3.5. I don't want that. So what I do is this. I need to make this even. Need to be an even number. So I take 1 away. Take 1 away. Okay, so I'll stop for a second. And right up here, I'm going to write a little note for you. Okay, I know this. I know this, and you do too. I know that if I had x to the 6th times x to the 1, that is x to the 7th. Hopefully you know that. Hopefully that makes sense to you. So I'm going to do the same thing here. I'm going to rewrite this x to the 7th as a square root of x to the 6th times an x to the 1. The reason I wanted to do that is then I can take, it's even, and I can take half of it, right? Because that's what I want to do is take half of the exponent if I can. So now I can take half of that. So let's go. Let's do it. Let's do it. So that becomes square root of 9. We know that. That's a 3. The square root of 3, ugly number, irrational. Leave it alone. But here we can take half. We can take half of this. Half of the exponent makes x to the 3rd. So when I do that, I'm taking the square root. When I take half of it, I'm taking the square root, so it comes out as x to the 3rd. No longer a square root symbol because I took the square root of it by taking half of it. Now, what's left? Well, there's a couple things left that we can't do anything with. Square root of 3, it's an irrational number. And the square root of x to the, just plain the square root of x, you can't do anything with it because you can't take half of 1. So we're going to leave this as the square root. These two have to stay inside of 3x. Okay, and that is my answer. Okay. Oh no, it's not my answer. Oh, got carried away because I can do this 3 times 3. Well, come on, Mr. Davies. What's 3 times 3? 9. then x to the third, then the square root of 3x. That's my simplified answer. Oh, almost forgot 3 times 3. Okay, we will do this together in Zoom. We'll practice this, okay? Now, what about cube roots? Well, cube roots are a number times a number times a number. Let's see, so 1 is a cube root, but so is 8. 8's a perfect cube root because 2 times 2 times 2 is 8. Well, what about 27? Yes, 3 times 3 times 3, right? Let's see, what about, let's see, 4 times, what about 64? Yeah, because 4 times 4 times 4. And then what about 125? Yeah, and I'm not, let me get my calculator. I think it's 216. Oh, I think it's 216. Clear. Let's see, 6 to the third power is 216. I'll bet, yep, 216. What about 7 to the third power? I don't know, 7 to the third power. Let's see, what is that? 343. And what about 8 to the third power? 512. Okay, let's see. So that means I know that the cube root of 1 is 1. I know the cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5. The cube root of 216 is 6. I know the cube root of 343 is 7. And the cube root of 512 is 8. Okay? Now, my calculator will do cube roots. I don't know if yours will, but mine will do. If I go to my math button, I can do a cube root. Some of your calculators on your phones will do it too. If you turn your phone sideways, some of your calculators will do it, okay? Anyway, let's take a look at the cube root of 24. So same thing. We're going to break it down. I want multiples, okay? I want multiples. But I want the multiples, since it's cube root, I want one of these. Okay, I want one of these. So what times what makes 24? Well, how about 8? Because that's one of these. I want a perfect cube root. I'm looking for a perfect cube root because I can take the cube root of 8. So let's go ahead and rewrite this as the cube root of 8 times the cube root of, well, 8 times what? 8 times 3, right? Now, cube root of 8, we know, is 2 times 2 times 2. So the cube root of 8 is 2 times the cube root of 3, which the cube root of 3 is an irrational number. If you wanted to do it and check it out, the cube root of 3 is just a bad irrational number. There it is. So we're going to leave it as the cube root of 3. Otherwise, it's just this ugly decimal. Okay. All right, example 9. So on example 9, let's check this out. Well, 250. It's got to be one of these numbers. We need one of these numbers because these are my perfect cube roots. 125. 125 times 2. Yeah, 125 times 2. So I'm going to write this as the cube root of 125, cube root of 2. And then, instead of taking half the exponent, what do you think? We're going to take a third. We're going to divide it by 3. So we want to take a third of my exponent. And I can take a third of 6 or divide it by 3 and I get x squared. Okay, once I take the third, I've performed the square root, or in this case the cube root. Once I've taken the third, I've done the cube root, so it comes out. I've done it. Now, one more thing I can do here is I can take the cube root of 125 because I know that 5 times 5 times 5 is 125. So this becomes a 5. The x squared is already done. I'm going to put it next to the 5, so 5x squared. And then the cube root of 2 is an ugly, irrational number, cube root of 2. Okay, there we go. All right, slide up. Example 10. Well, let's see. My goodness gracious, cube root 60. Is it any of these numbers? I think 729 is a perfect cube root. I don't think we went far enough, but if I use my calculator, let's see, calculator, if I go to cube root, I think it'll do it. 729, I think, is a perfect cube root. Yeah, it's 9. So what I know is this, okay, just use my calculator, that this is going to be a 9. So on the bottom, or denominator, I'm going to have a 9. And I'm going to take a third. I'm going to take a third of that. I'm going to get a y to the fourth. Now the 60. What times what makes 60? Well, 2 times 30, 3 times 15. So there's nothing. Absolutely nothing. So this has to just stay the way it is. A little negative out in front. Cube root of a 60x squared. That's about all I can do. Done. Okay. So we'll talk about this again in Zoom. I'll go over it one more time. And the homework is in the journal. We're only doing one page, and tomorrow we'll do the other page. So stop it right there.